Okay, here we are doing page 7 and 8 of the core mock exam. Now we're going to graph the log function. And in the case of the log function, it's pretty similar to the exponential function. We have the log base 2 of x minus h plus k, and you might want to write that down on your note sheet. Okay, all right. And remember, H and K give us the translations, horizontal and vertical translations. So in this case, the horizontal translation is 1 and vertical translation is 2. And our parent function would be log base 2 of x. And the way you would graph log base 2 of x is with your little table. And remember that whenever you put certain values into log, you can figure it out even without the calculator, okay? But since you have the calculator, you can actually check your values, right? So if x equals 0, the log value is nothing because, or it's like invalid, because remember the snail method, right? So snail method, to do snail method, you need to put the log on the left and the number on the right. So we're going to have log base 2 of x equals y, and then we're going to do the snail. And the way you do the snail is you say, okay, if I start with log, I want to make it into an exponent expression, which is easier to understand. So you're going to say 2 to the y is x. So you're going to say 2 to the y is equal to x. So we've just changed the log function into an exponent function. And if you want to, you could write that little example on your note sheet, or snail examples on your note sheet, or whatever. So if we have 2 to the y equals x, we can kind of use this to figure out important values for this table. Okay, so like for example, if we put 1 here for x, that would mean 2 to the what equals 1. Well, remember Donina said, well actually you never had Donina, but the 2 to the 0 is 1, okay? Any number to the 0 is 1. Okay, what about if we had 2 here? Well, if we had 2 here, 2 to the what is 2? Well, 2 to the 1 is 2, right? Okay, and so that's enough for now. Now we can take those values and we can actually draw our initial graph. So 0 and nothing, what that means is that at 0, the parent function is an asymptote. And then we put 1 comma 0, and then we put 2 comma 1. Okay? And so if we were going to graph the parent function, it would look kind of like that. Okay? Now we are going to, we already drew the asymptote. We drew the asymptote at x equals 0. Okay, so the parent function asymptote is x equals 0. Okay, now what happens if we translate the transform function 1 to the right and 2 up? What does that look like? So now what I'm going to do is I'm going to take each one of these points and I'm going to move them, what is it? 1 to the right and 2 up. So 1, 2. 1, 2. And then the asymptote, we can also move 1, 2. And like the asymptote actually doesn't go up, right? So it only matters that it moved to the right. So our asymptote is at x equals 1, right? Because it moved over slightly. So that's our asymptote. And then we can draw our function kind of like that. We could get one more point that's pretty easy, right? We could say that the log of 4 is 2, right? Because 2 squared is 4. So we'll draw 4 comma 2 here. That'll give us one more good point. And then we can translate that point. 1, 2. Okay? All right. So that is our graph. Oh, and it says to draw the asymptote, and it says to write the equation of the asymptote. The equation of the asymptote for the transform function is x equals 1. Write down the domain and range of the function. Okay, now if you look at the domain of the blue function, you can see that it does not exist on the left side of this line. It only exists on the right side of this line. So it's like x is greater than 0, right? Is it like is x is greater than 1? Is it x is greater than 1, or is it x is greater than or equal to 1? Well, you can see that it's an asymptote. It never touches it. So it would be x is greater than 1. Okay? And what is that? Is that the domain or the range? Well, it's the domain, because the domain is the x part, right? The range of the would be the y part, and you can see that for y values, the blue function goes up and down forever. So you could say y is all real numbers. Okay? All right, let's move on to page 8. Solve for x. So when you get an expression like this, and you have exponents, and you need to solve for the exponent, this is like a solvable problem. And the first thing you're going to do is you're going to say, hey, wait a second. If I could make both sides into the same base, like if I have 7 to the x is equal to 7 to the x, 2x plus 1 or something. You could like, as long as you have the same base, you can make these two the same, because if this is 7 something and this is 7 to the something, the two exponents have to be the same, right? So we use that trick. When you see this, try to make the bases the same. So I have 2 on the left and 32 on the right. Those are not the same, okay? But remember, 32 is a power of 2. In fact, it's 2 to the 5th, okay? So you could write 2 to the x minus 4 equals 2 to the 5th to the x power. Do you see how I rewrote 32 to the x as 2 to the 5th to the x? Then you use one of the exponent rules that if you have a power to a power, you multiply them together, right? So now I'm going to rewrite it. I have 2 to the x minus 4. Now I'm going to write that as 2 to the 5x, because I'm going to multiply the exponents because power to a power. Okay, now that I have it in this form, I can see that I can equate the exponents, because I have 2 to the something equals 2 to the something. The somethings have to be the same. So I can write this algebraic equation here, and now it's a 7th grade algebra problem. I can subtract x from both sides, and I will get 4x equals negative 4, and that can be solved. That would be x equals negative 1, right? I divide both sides by 4, and I'll get x equals negative 1 is the answer. Okay? Now I'm going to go down to 16, solve for x. It's a similar type of equation. In this case, the snail method, I think, is one of the best ways to do it. You could say, okay, I want to convert this into exponent expression because it's a little easier to understand. So you say 2 to the third is equal to this. So I'm going to write 2 to the third is equal to 4 minus 2x. And now it's like an algebra equation. Actually, 2 to the third, 2 times 2 times 2 is 8, right? So now it's a really easy algebra equation. Subtract 4 from both sides, I get negative 2x. Divide both sides by negative 2, and I get that x is equal to negative 2. Okay? All right. If you want to check these, you could take the negative 2 and you stick it back in for x, and then you can figure out if it actually equates. Okay. Last one on this page. A cup of hot water is left out to cool. The water is currently 28 Celsius above room temperature. Room temperature is, about like 20-something degrees, right? Doesn't matter, though, because they're just saying 28 Celsius above room temperature. If the heat decreases by 10% every minute, what will be the difference in 14 minutes? Okay, so let's see. If the heat continues the same, then the way you calculate the temperature from one time to another is you just multiply it times 100%. So let's say that you're 28 C above room temperature, and you want to see what you multiply times in order to get the new temperature. You just multiply by 100%. Okay? Now, if I want to make it decrease by 10% every minute, then what I want to multiply by is 100 minus 10%. Does that make sense? So if I'm decreasing, then what do? I multiply by 10% less than 100, which is the same thing as multiplying by 90%. Okay? Remember, 90% is the same thing as 0.9. Okay? All right. So what I'm going to do is I'm going to take 28, and I'm going to multiply by 0.9, because it's 90%. And then I'm going to do that 10% every minute. So I'm going to do that for 14 minutes. So that means I'm going to multiply by 0.9 14 times. Oh my God, what a pain. Wait a second, that's why we have powers. So we're going to do 28 times 0.9 to the 14th power. Okay? And let's see what that gives me. Okay, so I'm going to type in here 28 times 0.9 to the 14th power. 6.4. And it says to the nearest tenth, so 6.4 is just fine. Okay, the amount of bacteria in a tub of rainwater doubles every 2 days. If the number of bacteria is 5,000 at the beginning, how many bacteria after 8 days? So, 5,000 is the initial amount. If I double, it's going to be 10,000. If I double after that, it's going to be 20,000, etc. Okay, so how many times am I doubling? I think it helps to draw a picture. So if I have 8 days, I drew 8 days there, then how many times do I double? Well, remember, I double every 2 days. So like I'm going to double once here, double twice, double 3 times, double 4 times. So I'm doubling 4 times in 8 days. So that means I'm going to take 5,000 and I'm going to multiply by 2 4 times. So the answer is going to be 5,000 times 2 to the 4th power, which is 80,000. Okay? All right. And that is the end of page 8. So we're going to stop here and make a new video.